Okay, kids, here we go. 3U, Chapter 2, Assignment, Question 10. It says, in an electronic tube. So, oh, come on now. There we go. In an electronic tube, an electron. So I'm going to do G for given. There's the tube. An electron. Okay, let me draw the electron. Here it is. There's the electron. And we know the mass of it, so we better write that down. Notice how I'm using G for given. 9.1 times 10 to the negative 31 kilograms. Experiences a net force of 8.0 times 10 to the negative 15 newtons. So let's make this direction positive, right? So its net force would be plus 8.0 times 10 to the negative 15 newtons over a distance of 2 centimeters. So the force is experienced while it moves forward for 2 centimeters. Oops, let me redraw that. That's horrible. Sometimes my pencil is not my friend. 2.0 centimeters. So it experiences this force for 2 centimeters. Well, that 2 centimeters is displacement. Okay? But we don't use centimeters, we use meters. So it has to become positive 0.02 meters. Okay? So, required. Well, in part A, they want us to find acceleration. Analysis. I have to pick an equation. Is there an equation out there that will let you find acceleration if you know net force and mass? Does such an equation exist? It does. I'm not going to tell you what it is, but it exists. Okay? If you know mass and you know the net force, you should find an equation for acceleration. So that's part A. Part B. Part B, the required is how fast would it be traveling at the end of the 2 centimeters. So look up here. The electron starts right there. And then a little bit later in time, it's going to be here, 2 centimeters down the road, right? We want to find out how fast is it moving when it's right there. So really, what they're asking for in part B for required is what is its final velocity? What is its final velocity after it's been accelerating for 0.02 meters forward, or positive 0.2 meters, okay? What is its final velocity? What else do they tell us? It says, assuming it started from rest, how fast would the electron be traveling at the end of that 2 centimeter motion? So what they're saying is that when the electron was right here, so the electron is right there, it was at rest. Well, what information is that? It's at rest. It's not moving. Right? It's telling you that when this whole thing started, look here, kids, it's telling you that the initial velocity was what? Nobody knows. It started from rest. Yes, 0. So here's what you need to think about. Okay, here's what you need to think about. Okay, you need to find you need to find final velocity, right? What do you know? Well, from part A, look what you got in part A. I got acceleration, right? So I want to find final velocity. From part A, I got acceleration. From the given information, look what you get from the given information. Displacement and initial velocity. So you know initial velocity is 0, and you know the displacement was positive 0.02 meters. Is there an equation out there? Now, I'm not going to tell you this. Is there an equation out there? This would be the analysis part, right? Is there an equation out there that will let you find final velocity, if you know acceleration, which you calculated in part A, you know the initial velocity because it was starting from rest, and you were told it moves 2 centimeters or 0.02 meters. Is there an equation that will let you calculate that? I bet you there is. Is this helping you? Okay. Okay, bye-bye.